Hello, hello. How are you? I hope you're good. Um, my name is Nicholas Sukumani. My academic background, I hold a BSc degree in environmental science from the University of Venda. I also hold an honors degree in geography from the University of Johannesburg. And currently, I'm doing my master's in environmental management at the same University of Johannesburg. And I will be covering plate tectonics with you guys. So let's get into it. I hope you're ready. So this is our hierarchy of models. Remember our hierarchy of models, we are using it to follow that story, to answer that one important question, which is why is our Earth habitable? So in the beginning, if you remember, we introduced a core talk called In the Beginning, right? Where we introduce that is the distance from the sun enough to make our Earth habitable? And the answer for that was what? Was no. At the end, our Earth was way, way, way too cold at minus 18 degrees. We then introduced light and air. Did that make our Earth habitable? No. At the end, our Earth was way too hot, right? We then introduced circulation atmosphere and circulation oceans. That kind of helped with regulating our temperature, as it was now able to be distributed what? All over the Earth, all over our model Earth. So now we are coming into drifting continents, where we'll be covering plate tectonics. So this is, I hope this is not your first time seeing this diagram, as you also saw it in the last talk. So in our y-axis, that's the temperature in degrees Celsius, and in the x-axis we have the number of years going back from the present to 60 million years ago. So in the last core talk, you learned what happened between the present and 3 million years ago. If you check there, the temperature, it's dropping, then it increases, it's dropping, it's like it's making this wave. So in the last core talk, you learned that drop in temperature, that drop going up and down and up and down in the temperature, it was caused by the what? By the Milankovitch cycle. So with our core talk, we're gonna be looking into what happened now between 3 million years ago and 60 million years ago. Something funny is happening there. If you check between 3 million and 60 million years ago, there's a what? There's a drop in temperature. So within this core talk, we're gonna be looking at what exactly happened. I hope now you are with me. So to answer that question, we're gonna look into the structure of our Earth. Here we're gonna look into how our Earth looks from the inside and how our Earth looks from what? From the outside. We're also going to look at the history and mechanism of plate tectonics. Here we're gonna be looking at how did the theory of plate tectonics come about, and what other theories help justify the plate tectonics theory. And we're going to also look into how do plate tectonics make our Earth what? Habitable. And also we're going to look into why is South Africa a special place in a special time. So now let's jump straight into the structure of our Earth. So if you open your Google Maps now and you zoom out, this is the picture you're going to get. I'm sure even in high school, if you did geography or any other subject, whenever they teach you about the Earth, this is the image they use. It might not be this one exactly, but something similar, right? But what if I tell you that our Earth didn't always look like this? I hope you're not shocked by that. But our Earth didn't always look like this. I will explain as we go on. So how does our Earth look from the inside? So our Earth is made up of what we call the core, the inner core, the mantle, and also the crust. So what's interesting about the crust is we have two types. We have the continental crust and we have the oceanic crust. So a very good example of this is the peach. If you have eaten a peach before, you will know that from the inside it has a stone. That stone can act as our what? As our core. We then have the flesh. The flesh can be our what? Our mantle. We then also have the skin, which you can peel off. Those ladies, if you have long nails, you can easily peel off the what? The skin. The skin can act with as our what? As our crust. So by now you know how our Earth looks from the outside and also from the what? From the inside. So now let's look into the history and mechanism of plate tectonics. So what are plate tectonics? So in simple words, plate tectonics, this is a theory that explains the Earth structure, right? It further states that the Earth's surface is cracked into large pieces, which we then called what? Plates. And it didn't just end there. It further states that these plates are slowly moving away from each other, right? So who came up with this theory? This theory, the man himself, his name is Alfred Wegener. In 1912, he came up with the theory which he called the continental drift. In other books, it might be called the Pangaea theory. But in simple words, his theory stated that these plates that we know today are slowly moving away from each other. Whoa. So his theory further states that 200 million years ago, these plates that we know today were one thing. They were all together, which was called Pangaea. And it was until 150 million years ago where these plates started what? To move away from each other. We then had Laurasia and Gondwana, right? And 100 million years ago, that's when these plates, it was now more visible that they were now moving away from each other, because we now had America, South America, and so on, until today. So it started from Pangaea when they were together until today when they are what? Until the Earth as we know it today, where we have Africa and so on. So what's a theory without evidence? I mean, if I'm stating something, I have to give evidence, right? So what evidence did Alfred Wegener give? Let's look into those now. So the first one is the jigsaw puzzle. So I don't know if it's just me, but back in high school, I would look into South America and Africa, and I'd be like, something funny is happening. So what's interesting is Alfred Wegener also thought the same thing. He looked at the map of South America and Africa, and he was like, wait a minute, these two things can fit together. That was the first evidence that he gave when he looked at South America and Africa, and he was like, no man, these two, it's like they can fit back together like a what? Like a puzzle. That was the first evidence he gave. So the second evidence that Alfred Wegener gave, right, it was the distribution of fossils. Alfred Wegener found that some of the fossils that are being found in South America are being found in some parts of Africa, and some of the fossils that are being found also in Africa are being found in India, Antarctica, Australia. This also supported his theory that no, these continents, they were one thing until they separated, because what's found in another continent is being found in another, showing that they were one thing, right? The third evidence that Alfred Wegener was the geological evidences, the rocks, right? He found that some of the rocks that are being found in southern parts of Africa are also being found in Southern America. Some of the rocks that are being found in Northern Africa are also being found in some parts of Europe and also North America. Further supporting his theory that what? These rocks, these continents, they were what? They were one thing. So the disappointing thing is, after providing all these evidences, the Pangaea theory or the continental theory was still rejected. Imagine. This was until 1929 when a man by Arthur Holmes came along. Arthur Holmes came with a theory called the conversion salts theory, right? So what did this theory state? Let's get into that. So Arthur Holmes theory states that the Earth is being heated from the ground by the what? By the core. So what happens is, if you look into our figure 15, when the core heats up from the bottom, the magma that's right there gets heated, when it gets heated, it becomes less dense, and it goes up. When it goes up, it cools. When it cools, it sinks again, creating that circular movement, right? When that happens, the earth or the plates that are there at the top, they start to move away from each other. So what happens is, when the core heats up, the magma gets heated. When it gets heated, there's that movement. The magma that's at the top, when it becomes less dense, it sinks. When it sinks, it gets heated, it goes up again. When that movement happens, right there at the top, the plate starts to move away from each other. A good example of this, it's in figure 16. Imagine you are cooking. When you are cooking, right, the water gets heated from the bottom, right, going up. The water at the top, because it's cooler, it sinks, and when it gets to the bottom, it gets heated again, it goes up. Then the water at the top, it cools, it sinks, and so it creates that movement. And there at the top, it forces the plates to move away from each other. So what are the recent evidences of plate tectonics? The recent evidence is that Africa is now splitting into two. Right? The good news about this is, those in Limpopo, if you check there, we will soon be getting a beach. Those of us who are from Limpopo, guys, you don't need to travel to Cape Town or to Durban again. The beach is coming to us. So recap. So far you have now learned that how our Earth looks from the inside, and also from the outside. We then also looked into the theory that Alfred Wegener gave of the Pangea theory, or the continental drift theory. We also then looked into the Arthur Holmes theory that stated that the Earth is being heated from the ground going up, and that causes these plates to move away from each other. Now, how you might be asking yourself, yes, I get that continents move away from each other, but how do they move, right? So we have types of plate boundaries that will help us explain this on how they move. So we have the convergent boundaries. This is when two plates are moving towards each other. We have the divergent boundaries. This is when two plates are moving away from each other. We then also have transform boundaries. This is when two plates are moving past each other. So let's start with convergent plate boundaries. Here we have three types. The first one being oceanic continental. This happens when the ocean moves towards the land. But because the ocean is cold and it's more dense, when they meet, the ocean does what? It sinks because it's colder, right? Whenever this happens, a little bit of the magma is able to escape to the surface, like it's there, like you can see there in figure 22. The second one is oceanic. This happens when two oceans move towards each other, right? But because the other ocean is colder, when they meet, the colder ocean, because it's more dense, it then it sinks because it's cold, right? And also here, when these two oceans meet, a little bit of the magma is able to escape to the surface. The next one, we have continental. This is when two continents move out towards each other. But because here we don't have more dense or less dense, when they meet, instead of one of them sinking, it does there's upliftment. That's how our mountains form. So what are the effects of convergent plate boundary? Like I said, the formation of mountains, that's one example. And also volcanic eruptions. Remember I said when the oceanic and continental meet, a little bit of the magma is able to escape to the surface, creating a volcanic eruptions. So now let's look into divergent plate boundaries. Like I said, with divergent plate boundaries, this is when two plates are moving away from each other. A very good example of this is the valleys. Valleys they form when plates are splitting into two or moving away from each other. So if you can check in figure 28, this one is moving this side, the other one is moving this side, and it creates a split in between, which we call the what? The valleys. So our third example is the what? The transform plate boundary. This happens when two plates move past what? Each other. So if you check there, they are moving in opposite directions. But what if I tell you it can also happen when these plates are moving in the same direction? But what makes it be called the transform plate boundaries? They can move in the same direction, but in different speeds. Right? So what are the effects of these transform plate boundaries? A very good example is earthquakes. Whenever these plates are moving past each other, it causes a vibration there, which then causes what? Earthquakes. So let's look at our overview again. Now you have learned about how our Earth looks from the inside and outside. We also looked into the history and mechanism of plate tectonics, looking into our two theories. We then also looked into so now let's jump straight into what? Plate tectonics and how they make our Earth habitable. So a very good example of this, I just gave you two examples there. It's Mount Kilimanjaro and the South Berg Mountains in Limpopo. So with plate tectonics, they are able to create diverse habitats and ecosystems through what? Continental collision and upliftment. Now we are able to enjoy this scenario where some of you can even go to vacations there. And also they also give birth to diverse habitats which are able to sustain different types of animals or people, right? That's where in Kilimanjaro you find different types of animals, because that ecosystem is able to take care of those animals. So it's able to create diverse habitats, right? The next one is volcanic eruptions. I don't know, many of you whenever you hear about volcanic eruption, you only think about the bad things. But what if I tell you that volcanic eruptions are some of the things that we need to survive? Because a very good example, when volcanic eruptions occur, water vapor is emitted, so we need that to survive. That's one of the, and also other gases that we need are also being produced by what? By volcanic eruptions. So now let's come back to this graph. Remember I told you that from the present, which is our 0 to 3 million years ago, that change in temperature, it was caused by the Milankovitch cycle. And with our core talk, we were looking into what happened between 3 million years ago and 60 million years ago. There was that drop in temperature. Now I can tell you that that drop in temperature was caused by plate tectonics. Right? If you check 60 million years ago, our continents, they were together, they were one thing. But once they started to move away from each other, that's when the temperature dropped. Right? So one of the things that happened is when the continents are together, right, and they started to move away from each other. The funny thing that happens is Antarctica it moves away from the rest of the plates, and it stands alone. When it's alone, the ocean now is able to move around it. When when it moves around it, Antarctica, what we know about Antarctica is that it gets cold, and when it's cold, snow forms. And what do we know about snow? Snow has high what? Albedo, meaning whenever the sun hits our earth, right? It hits our earth. Antarctica works as a mirror, which when the sun rays hit our earth, Antarctica sends it back, right? When it sends it back, it means our temperature then does what? It drops, right? It drops because Antarctica is working as a mirror. High albedo, it means it has high reflectivity, right? The temperature is now being sent back. And not just that, when these continents move away from each other, the heat distribution is now, you learned this with circulation ocean and circulation atmosphere. when the plates are away from each other, we are able to what the temperatures being able to be regulated with our oceans and our atmosphere. That plays part into our temperature what dropping. Did you get it? I hope I explained it better. So why is South Africa such a special place, right? If you remember, we talked about earthquakes. If you check in figure 36, in other countries like Japan and China, whenever they get hit by earthquakes, they lose their homes, they lose their cars, they lose their roads. In fact, the damage is so intense that it takes forever to fix, right? That's how Japan, they now introduced these paper houses so that they can easily rebuild them. But what about us in South Africa? Whenever we get hit by an earthquake, we are able to repair it easily. Like if we check in the figure there, whenever an earthquake hits South Africa, a chair simply falls, and to fix the damage, we simply just pick up the chair. What if I tell you that in Johannesburg this year of 2025 there was an earthquake? And what if I tell you that in Northern Cape last year December there was an earthquake? Would you believe me? Some of you may not, because you don't even know about it, because that's how little we take earthquakes, because this side we don't have such intense earthquake. But I challenge you, after watching this core talk, go to TikTok and search I survived an earthquake, especially in Johannesburg. You will see there's a trend of people laughing that there was an earthquake but nothing happened. That's how special we are. So, in summary, for this core talk, we learned about the structure of our Earth, how it looks from inside and how it looks from the outside. We also looked into the theory and mechanism of plate tectonics. We looked into Alfred Wegener and Arthur Holmes and their theory and how they supported each other. We then looked into how plate tectonics make our Earth habitable. And we also looked into special place, special time about South Africa. How is South Africa special? So I hope you enjoyed our core talk, and with that I say danko. Thank you.